All right, now in part 2 of our vector tutorial, we're going to pick up from part 1 where we had created this vector data structure and written some functions and to work with it. What we're going to do now is we're going to create a header file and another .c file. So far in our project, we simply have this main.c file. What we want to do is we want to then create a header file. We put our function prototypes in the header file, and we hadn't written any prototypes. Let's go ahead and do that right now. Let's go ahead and say, all right, these are our vector function prototypes. And the prototype is simply the function heading followed by a semicolon. All right. There's this prototype. There's this prototype. Right. And then below, these were our vector function declarations or definitions, right, where we actually then define the behavior. Right? We write the function header. Inside the curly brackets, we define the behavior of the function. Right? What we want to do is you want to get to the point where you just have only your main function, your main.c file, and any sort of global declarations that you need to make. We're going to create something called a header file now. You've been including header files for a while, right? Standard.io.h, that's a header file. Math.h, that's a header file. It contains mainly function prototypes, possibly some comments, and possibly other global definitions. So to create your own header file, right, we're going to say File, New, File, New File. And now we come up with these choices. We've been choosing C. Now we want to choose C header. So say go, and it asks you where you want to save this. Here I want to make sure I put it in my project folder. So this is going to be named vector. And if I don't give it an extension, it'll give it something like .h or .hh. Well, I'm just going to say vector.h. So header files end with a .h extension. I'll save that. I want to make sure it's part of my debug configuration if I want to use the debugger to step through it. And now when I say finish, we get a file that looks like this. This is called a header guard. This is a preprocessor directive. Remember, everything that starts with a pound sign is a preprocessor directive. This says, if not defined, define a macro called vector_h included. So what CodeBlocks did is it took the name of the file vector, so put everything in caps, so vector_h for header _included. You can name this macro basically anything you want, but we go with this convention. So name of the file and then included. So if that's not defined, this says pound define, go ahead and define it. Right? This is like an if statement, basically saying if vector.h hasn't already been defined somewhere, go ahead and define it. And then at the end of the file, we always have this pound end if. Right? So this is what we call our macro guard, and we always put these in header files. What happens is later, if you have to include this header file in more than one place, it prevents then multiple definitions of the same functions being put into the file. It actually, what it does is it says just exactly what it says here. If this hasn't been defined, go ahead and define it. Probably better show you an example of that later when we start using this in multiple places. So for right now, just know that you always put a header guard on your header file. When you use something like CodeBlocks, it creates this header guard for you. If you're using your own text editor, you're going to have to follow the same format. We say pound if not defined, pound defined, and then pound end if. That ends then this if condition. In here is where you'll put your function prototype. So all we're going to do now is we're going to pull these out of main. Right. I'm going to cut these out, and I'm going to put these in here. Right. We don't write code inside of header files. We don't write code in terms of, I wouldn't write a function declaration here. Actually, header files are not compiled. Right. Now, the other thing I want to do is I want to put my definition here inside this header file. Let's go do this. Let's go ahead and take our comment here. right, which now goes with this. Right, so we can put comments right here inside the header file. So now I've defined our structure, right, our vector structure. I've defined the prototype. I pulled that out of main. Now, in order for main to know about this, I have to then tell main that I want to include this header file. So besides here, besides standard.io.h and math.h that we were using, I'm going to say pound include. Sorry. And when we have these local files, we use the double quotes. So I'm going to say vector.h. So I have to include whatever I name my file. Here I named it vector.h because this is local to the project. We put the double quotes around it. These angle brackets are for libraries that were installed when your C compiler were installed. You want code blocks or any environment, whenever you compile this, to look locally within the same folder. That's the first place it's going to look, and that's what the double quotes tell it, is that this should be declared within the same folder, right, in the same directory path. You can also specify directory paths to its location, but for now, just go ahead and put it in your same folder. When we include this, then it will be able to go over here and find where we define this struct, right, and where we defined the prototypes for this function. The next thing we do is we're going to create a .c file. So file, new, file. And we're going to call this vector.c. Right. And so store that in your same project directory, vector.c. Right. Make sure that's part of your debug configuration so you can use the debugger. And what we do here is we now say include vector.h. This gives this file access to these prototypes. And what we do here is we put the vector function definitions in this file. So I'm going to cut these from here, put these over here. Right. And so we always have, what we do is we name the header file vector.h. The C file that goes with it, we usually give the same name, so vector.c. We always have to include vector.h so it knows where to look for the prototypes of these functions. Right. Now back here in main, right, now notice also we have 3 files in our project. We have vector.h, we have header files, we have 2 source files. Right. Because I've included vector.h here, well, let me just go ahead and compile main. All right. Main looks happy. All right. I can compile the .c file here. All right. But when I do that, this file is not quite as happy because right here it says implicit declaration of printf. Right. This C file is trying to access printf. It doesn't know anything about printf. Right, so what we also have to do here is we have to include standard.io.h. Right. Similarly, this doesn't know anything about the math library. So I'm going to pound include math.h. Right, so any of the C libraries that we're accessing from within a .c file, we have to include that. So now I can recompile. Right, I get rid of that information there, or sorry, I get rid of those warnings. Now let's look back over here. Because this file is not using the math library anymore, we don't include this here. Right, we only include the files we need. Now main is accessing printf, so we need to include standard.io here. Right, so if we compile that, right, in this case, right, once again we get no warnings. We still need to build. When we build, it's going to build against all 3 of these files. Right? So if I build, right, it links everything together. And now if we run this, right, we find we get the same results as we did as it was when it was in all one file. Right? And that's what we were hoping for. Right. We started doing this because we've been telling you, right, I've been telling you all semester that code should be reusable. Well, now when I can start putting things out in their own files, right, when I can start putting these functions out here, once we create these files, we can start using these files in other projects, right? I can then start bringing in vector.h in other projects, right, which will give me access to the functions in vector.c. And be able to use it in any other source program. Here we're using it in main. Notice now all we have here is our main function. Right. I'm going to go ahead, I'm going to clean the workspace. Right. So here I'm going to comment out this include for vector.h. I'm going to comment that out, and I'm going to compile, and we're going to get errors. We get errors saying unknown type vector. Right. I wanted to show you that if you don't include vector.h, vector.h is where this type definition is defined. So if you don't include that here, you get all kinds of errors. Right? So when you see yourself getting errors, unknown data type vector, and you say, oh, well, I declared that, you have to say, where did I declare it? Well, you should be declaring these structs then in these header files. So in this case, this would tell you you need to include this here. Right? We recompile, it's happy again. Right? I'm going to clean the workspace again. Right? And you don't have to compile all these individually. Right? You can compile, if you say build, it'll compile all of these. Right? What I want to do is I want to introduce an error here. So let me purposely misspell printf. Right? And now if I compile, it'll just compile this file. Right? And it'll come up and tell me implicit declaration of function print. Right? So I know where to correct that. All right. If I recompile, that goes away. All right. Now, so if we don't compile files individually, right, if I make an error there, right, and let's make an error, let's make an error here in main as well. Let's just misspell vector. So now I'll just say build. When I say build, it's going to compile then main.c, vector.c. It's going to see if it can build this. Right, so first thing it does is it comes up and tells me unknown type vec. Right? Tells me what file it's in, and if I correct that, yeah, OR. Right? When I build again, it gets rid of all those errors, but now it comes up and tells me about this implicit declaration of function print, and it also shows me what file that's in. So now I can clear that. I build. Right? I've successfully rebuilt. So this environment's really good about telling you what file, where your error takes place. Right. Now, what happens if I change the way this is spelled here? Right. I'm going to change this from vector to vec. And what happens if I say build? Right. Notice then it comes up and it gives me an error here, and it starts complaining then about these definitions because these are spelled differently. Right? So I correct that. So it's showing me some errors in my header file as well too. So it's pretty good about showing you the different files where your errors are. Right. Same thing, build and run, no more errors. All right. So now you can follow this example to create header files. You can have as many header files in a project, as many .c files as you need. What we commonly do is we start writing libraries, right? We start writing, in this case I called it vector.c. In your homework, you'll do this. You'll have multiple files here that define then vector operations. You'll define all of your functions here, and then you'll need to put the prototypes here in the header file. Right, because C looks for these header files. We don't say pound include vector.c, we say pound include vector.h. And the H file then has your function prototypes, your structural definitions. Your C file then actually has your function behavior defined, right? Where you write all the information that defines how these functions run, like the code and that executes when these functions run. That's what we call function definitions. All right, so that should be enough to help you get your 3 files that you need for this homework.